The eighth mathematical habit of mind is look for and express regularity and repeated reasoning. The purpose of this habit of mind is to enable students to explore why a solution to a problem works, identify the most efficient pathway to solve the problem, investigate repeated calculations, and attend to details to evaluate reasonableness of results. Mathematical habit of mind 8 also empowers students to apply their mathematical reasoning and generalize the reasoning to other mathematical situations. Teachers should provide problem situations and mathematical tasks that encourage students to identify and use repeated reasoning, form generalizations, and communicate their rationalization to others. In geometry, one example of look for and express regularity and repeated reasoning is discovering the simple algebraic equations of rotations, reflections, and translations. By repeatedly performing a reflection, for example, students recognize the pattern among coordinates and on the graph. In applying look for and express regularity and repeated reasoning, a teacher may ask students, what do you notice in this situation? Is there a mathematical rule for this situation? Do you think this is always, sometimes, or never true? What would happen if we reflect over the y-axis instead? More simply, one may ask, what do you notice? What do you wonder? This type of questioning enables all students access to the content and provides avenues for students to do much more challenging mathematics. It lends to students making observations about the coordinates and graph and deciding whether these patterns hold true for every instance. By discovering the simple algebraic expressions, students will be able to find the coordinates of an image without graphing. Looking for and expressing regularity and repeated reasoning can also be applied to the idea that rigid motion maintains congruence. Students notice that reflecting, rotating, and translating triangles lead to congruent triangles. The initial problem connects back to the idea of congruency. Students recall the definition of congruent segments, and congruent angles. Students apply what they learned on previous days about transformations to link the idea of congruency in triangles. Matching the side lengths and angle measures of each triangle after a transformation, students will conclude congruent triangles exist because there are 3 pairs of congruent segments and 3 pairs of congruent angles. For this activity, students are asked to perform a given transformation. The goal is for students to notice that the size and shape of the triangles do not change after the transformation. Students make conjectures about the relationship between the pre-image and image. Based off what they've discussed previously, they will be able to write the triangle congruent statement and 6 corresponding congruent parts. Through repeated reasoning, students will see that rotations, reflections, and translations lead to congruent figures. By looking for and expressing regularity and repeated reasoning, students learn to observe patterns and develop curiosity as to why these patterns are happening. Teachers can engage in this habit of mind using activities or routines, such as notice and wonder, which helps our students' ability to recognize and respond to what they're given in a problem. This allows students to engage and explore mathematics through their own observations, so they develop mathematical reasoning behind mathematical shortcuts and algorithms.